Hello friends, in this video, we'll be discussing the bipolar junction transistor or BJT, which is a type of transistor. But before we proceed to the main topic, we must first understand how an LED works. Afterward, we will move on to creating a circuit using both PNP and NPN transistors. Lastly, we will discuss how to apply its function in real-life situation. Alright, let's talk about how an LED works. The positive terminal of an LED is usually the smaller metal part, while the negative terminal is the larger metal part that can be seen inside the LED. The negative terminal of an LED should be connected to the negative power supply. At this point, a resistor must be used to resist the current for LED to prevent it from shorting. The resistor should be connected between the positive terminal of the LED and the positive power supply. As we can see, the LED is connected in series with the resistor, which means that the voltage is shared between these two components. The voltage drop across the resistor is 2.165 volts, and the voltage drop across the LED is 2.831 volts, giving a total of approximately 5 volts. This 5 volts is the input voltage of the power supply. And now, let's move on to the main topic. We have here a 2N2907 transistor. And we will test it using a multimeter. We will set the multimeter to the diode test mode to determine whether this transistor is a PNP or NPN type. By using the method that I have provided, we can find two values ranging from 0.6 to 0.9 volts, while one probe is kept on the same pin of the transistor, either black or red, and the other pin is tested on the two other pins. The pin with the higher value will be identified as the emitter of the transistor, and this pin 1 is the emitter of this transistor. This transistor is a PNP transistor since the red probe is served as P and the black probe is served as N. If there are two P and one N in the transistor, it is a PNP transistor. At this point, we will be using a 5 volt DC supply. The emitter pin of the transistor is the input pin of the circuit. Connect the positive input to the emitter of transistor. By using an LED, the negative pin of the LED is connected to the board and the positive terminal of the LED is connected to the collector. By using 270 ohms resistor, connect the negative terminal of the LED to the negative power supply. And the base is connected in series to 20,000 ohms resistor. And by connecting the 20,000 ohms resistor to the negative, the circuit will open and the LED will be on. This is BC337 transistor. By using the method that I have provided, we can find two values ranging from 0.6 to 0.9 volts, while one probe is kept on the same pin of the transistor, either black or red, and the other pin is tested on the two other pins. The pin with the higher value will be identified as the emitter of the transistor. This transistor is a NPN transistor since the red probe is served as P and the black probe is served as N. If there are two N and one P, this resistor is in PN transistor. Since the pin 1 is 0.709 volts and the pin 3 is 0.710 volts, the pin 3 is the emitter because it has the higher voltage. The negative input is connected to the emitter. Since this transistor is in PN, the input is negative and the output is negative. And the negative of LED is connected to the collector of the transistor. By using 270 ohms resistor, connect the positive input to the positive terminal of the LED, and 20,000 ohms resistor from the base of the transistor to positive input, and it is the switch of this circuit. In application, the negative is remain connected to emitter of NPN transistor, and by using 20,000 ohms resistor, connect it to the positive, and it is a switch. By using this relay module, connect the GND of this relay module to the GND of the power supply, and the VCC to positive of the power supply, and the in to the collector of the transistor. And that's all. Before unscrew the screws of the relay, remove the power supply. Then we will use a bulb, and it is connected to the common and normally open of the relay. And that's it. This is the application of transistor.